we can use definite integrals to find the volume of a solid with square and rectangular cross sections. So suppose we have this curve y is equal to f of x. Well, the height of each square in this case is y. And because it's a square section, the width is also the same. So you can visualize these squares as being parallel to the YZ plane. And if we assign this square section an infinitesimal thickness, so that would be dx. Well, y squared, which is the area of the square section, multiplied by dx gives us the volume of that section. And then if we sum up the volumes of each of those square sections from x equals a to x equals b, which is what this integral does, then we find the volume of the solid formed by these square sections. So the solid looks something like this. Let's find the volume of a solid with square cross sections that are perpendicular to the x-axis. So effectively the square sections are parallel to the YZ plane, as you can visualize in 3D and 2D. And the base is bounded by the curve y equals x to 1/2, x equals 4, which is the vertical line, and the horizontal axis. So therefore, the vertical dimension of the square is described by y, and so is the horizontal dimension, because it's a square. So therefore the area of each square cross section along the horizontal axis is y squared. And we assign a thickness to the square, which is dx. And that gives the volume of one of those squares, and we integrate from 0 to 4 to obtain the volume of the entire solid, which looks something like this. Now y squared is x to the half squared, which is simply x, and now you can evaluate this integral quite easily. And post your answer in the comments. Find the volume of a solid with a circular base and square cross sections that are perpendicular to the horizontal axis. So therefore the sections lie in the YZ plane. And the diagonal of the square lies in the XY plane. So the 2D shape looks something like this. So the diagonal here is described by 2y, where we're going to take y as the positive root of that equation. And if we're using Pythagoras' theorem, we're going to obtain a length of one of these edges, which are all equal because it's a square section. So therefore the length of the diagonal squared is equal to a squared plus a squared. And therefore a is equal to root 2y. And therefore the area of that square is going to be 2y squared. And we give the section a thickness in the horizontal direction. And we integrate from x equals -1 to x equals 1 because the radius of the circle is 1. And that gives us the volume of the solid. So now substitute for y, evaluate the integral, and post your answer in the comments.